Now that we've spoke about the ohms values, we've talked about current resistance and current resistance and voltage, and we've looked at how current will flow through a particular resistor and relate those three values. I want to talk a little bit about energy and power in circuit diagrams themselves. When we talk about electrical power is the rate at which electrical energy is expended. So when current moves through a circuit, and it does work, think about if you're using any electrical device, current is flowing through that device. It's moving, you have it plugged into the wall, so it has a voltage of 120 joules per coulomb is moving as it moves through the outlet in the device. It does some work for you. You have some energy that's expended in there. You have light, you have heat, you have mechanical sound. You have all these different things our electrical devices do to it. And we want to be able to relate how much energy and power is being output by electrical devices based on how much voltage and current and resistance is associated with it. So we have an equation that relates the amount of current and voltage and resistance, depending on which way you're looking at it, the power that's being expended. We have this equation. This is in your reference tables, or at least the first part, power is equal to voltage times current. The other two are just iterations of it. Because voltage is equal to IR, you could say that it's IR squared. If you have two of the three ohmic values, you could figure out how much power is being used by any particular electrical device. You just need to know two of the three, voltage, current, or resistance. As long as you have two of those three, you can figure out the power rating of it. If you want to talk about the work being done by the object, so when we talk about how much energy is expended, this is what you buy from your energy company. They charge you for how much work that's done by electrical devices. Now you have to be able to still look at the power, but then also multiply it by how long the power rating is there. So if the object is 100 watts and it's running for an hour, you have that amount of power for that amount of time. Power times time gives you your particular amount of work done. And you can see here that we have all the different equations we had for power, voltage times current, current squared times resistance, voltage squared divided by resistance. And we've just taken all our power equations and multiplied them by time. We want to find out how much electrical energy has been expended by an electrical device. If we look at circuits themselves, so we've talked about circuits and we've talked about them in the general sense. I want to talk about what makes up a circuit very explicitly. Circuits themselves are a path of conductive material for charges to flow through. So in order for a circuit to be there, you need a voltage. There's got to be some energy source that is causing charge to flow through the conductive path. And then there needs to be the conductive path itself. So you always start your circuit with your voltage and power supply, and then you always connect your circuit by connecting some conductive path between the two terminals of your power supply. That is a circuit. Anytime that you have two terminals or two different points that have a different electrical potential energy between them, that means they have a potential difference between the 2 points. If you connect the 2 points with some sort of conductive path, the charge will flow from one to the other and you have a circuit. When we talk about circuits, it's important that we realize that most circuits, again, are connected by wires. Wires are conductors that are wrapped in insulators. The insulators keep the charges onto the wires. The conductors allow the charges to flow through them. When we look at circuits in this class, one of the things that we're going to look at is trying to understand ammeters and voltmeters. These are different measurement devices for measuring the voltage between 2 points in the circuit, and that's what a voltmeter does. A voltmeter measures how much potential difference or the voltage drop that we have between 2 points in the circuit. The ammeter is a tool that's used to measure the current in the circuit, and we will use these in class. One note about the ammeter: in order to properly measure the current that's running through a circuit, the current has to actually run through the ammeter. Finally, and we're going to see these in class, I just want to make sure these were in your notes. As we go into class and we start looking at making circuits and drawing circuit diagrams, I want you to have a list of the different symbols we use for circuits. So here we have the ones that we use in honors physics. Our power supplies will be represented by cells and batteries. Those are the first two. The switch is just like you've seen in your homes. These switches are used to turn power on and off. They connect the conductive path or disconnect the conductive path. Voltmeters and ammeters are represented by B's and A's. A resistor is a line that kind of has like mountains and valleys in it. And we have at the bottom a lamp, which is just a circle with a resistor inside of it. That's to show light bulbs or different devices. These are the symbols that we use from honors physics. We also have a couple ones specific to AP physics that we didn't see in honors. We're going to talk about capacitors, which are different devices that allow us to store energy, and inductors. And we'll describe these two once we get to them.